Okay, so here's this 6 marker done separately. We've got radio waves. Gamma radiation are opposite ends of the electromagnetic spectrum, so long wavelength to very high frequency waves. Compare how these two electromagnetic radiations are produced. This is quite a nasty question, to be fair. So let's quickly, I'm going to scribble loads of stuff on here first, and then I'll tidy it all up. So let's talk about radio waves first. What do we need to know? These are made in wires. If you imagine all the little electrons in here, and we know anytime I've got charged particles and I vibrate them, I make light. So radio waves are made by vibrating electrons. What this then does is it sends a radio wave. If you could imagine this as an antenna, so if you were to imagine this as a walkie-talkie, here's me talking into the walkie-talkie, and I get an electrical circuit to vibrate electrons backwards and forwards. Then it sends a radio wave. Off it goes. And then if I've got the antenna on the walkie-talkie, I've talked into there for the first bit. There's my antenna, Bravo 10-0, whatever it is. This then picks up that wave, and this causes electrons to vibrate. So there's radio waves in a nutshell. And the crucial part about these is humans make these in terms of circuits. So that's the basics there. So radio waves are made by vibrating electrons. This is done by humans, and we can use it for communication and things like that. Okay, next part, gamma. So gamma radiation. Well, we know that this is in nuclear decay. So this is from nucleuses. And so this isn't anything to do with electrons here. And we know this is completely random and spontaneous. And we know it happens when the nucleus, after a bit of alpha and beta, it's got some gaps in the nucleus, and we said it's when the nucleus rearranges itself. So it has a bit of a shuffle, sorts itself out, and this produces a very high frequency wave. Out it goes. So the crucial part about this is, well, this is completely natural. This just happens around us all the time. And that's kind of the basics. So radio waves, we're talking about electrons and vibrating electrons. Gamma radiation, we're talking about nuclear decay, and that the fact that the nucleus will have to rearrange itself, and this releases energy. We can even talk about here, we know that this is natural, but some will also be made in PET scanners. So we can actually have a positron will annihilate with an electron, 0, and then this will produce 2 gamma waves that are 180 degrees to each other, bing, and because we've got a sensor around, they can time this to locate exactly where the tumour is. So we've got this part here now. Well, the one predominantly made by humans for communication, the other one is natural, but humans do make some as well because we're amazing. So now I'm going to tidy all of that up into words. Rub-a-dub-a-dub-a-dub-a-dub. Go. And now we're away. So radio waves, these are produced by humans in circuits. We can vibrate electrons, and this will emit a radio wave of a given frequency. So you can see how different radio frequencies work. I just vibrate the electrons more or less of a given frequency. And that's enough. It actually doesn't say what they're used for, just produced, so I don't have to do the used bit. Brilliant. Okay, so that's radio waves done. And then gamma waves, or gamma radiation. This is the natural, I'm going to put random and spontaneous decay, random and spontaneous decay of radioisotopes. It occurs when a nucleus rearranges itself So I think that's kind of pretty much there. So naturally radioisotopes occurs when a nucleus rearranges itself. Got those keywords in there. I'm just going to have a quick look at the mark scheme. And we can just say though, so although it's natural, the last part is humans can produce them through PET scanners, or I'm going to show off now things like the Hadron Collider. How's that? And I think that's about it. But scan the mark scheme. I'm sure you could have written it a bit better than me. I've tried to just really abridge it and get the key ideas in there.